Hello and welcome to part 2 of this Vox 125 head. So we're going to start and put this amp back together. We've got this transformer which I've slid into here. Two of the holes match up. Probably just see if we go, we probably can't see because it's a bit awkward to get this tripod over where you can see there. So you can see I've got a hole there and I've got a hole, you can't see that one's being blocked by the transformer there, and I'm going to have to drill 2 more. But the other thing with this transformer is we don't know which wires do what, whatever. So I've been online and I've had a bit of a look to see if there's any data sheets for this transformer. Can't find one. I can't even find this listed on Dagnall's website. So we're going to have to do a bit of experimenting with some low voltage, some low AC voltage using the Variac to try and find out what all these windings do and where we need to connect to what. Because I've got 3 wires here, so is this the HT with the center tap, or is this 240 volts? Is this one 220 volts and this is neutral? I have no idea. Then I've got 2 tappings here and I've got 2 more there. Because I don't know what amplifier this has come off, if I knew exactly which amplifier this transformer had come off, I could go and look at the schematic and see if it had got a center tap, which would then tell me more than likely that this is the HT. These would be the filaments. On the other hand, these wires are quite thick, so these could be the filaments with a center tap. But then that doesn't really add up. And I've got another, what we got here? I've got 2 more here, spade terminals. They're going to tap-ins. I've got another one there, another one on the outside. So this is a minefield. We're going to have to work out exactly. The first thing we need to work out is which side the mains voltage AC is on. Of course, if you've worked on one of these before, these transformers, then you'll probably know, but I've not. So right, so I'm going to get on with that and see where we're going with it. So I'm going through this transformer and I'm testing the individual tap-ins against one another to try and find the right combination. This can be quite dangerous. And a typical example is I tapped onto one of these windings, and when I tested on this winding I'd got 247 volts and I'd got 15 going in. Well, that tells me obviously that that's not the right way to be connected it. But what it also tells me is that if I'd have touched those, I'd have got quite a nip off that. I touched those terminals and it was these 2. So you do have to be careful when you're doing this. Even you think you don't get, you know, roped into the fact that, oh, we've only got 15 volts on the Variac. One of these from 15 volts went to 247 volts. So you have to be careful. So we've now used this tap-in to feed in the voltage, and I've now fed in 20 volts, it says on that Variac, but it might be a little bit wayward. There's 25.8 volts going in there, and we've got 80 coming out of here, 81. So maybe that is the AC in from the power outlet, and this is the DC, the AC for the HT. It's looking rather like that. It's certainly not a filament winding. Now we've got these wires here, and if we just go from there to there, and then you can't see because my hand's in the way, but that there's a cable here, and I'm just these 2 cables here, I've got 9 volts on those, but I've also got a center tap on those, which is 4.5 a side. Now what could be happening with these tap-ins and these tap-ins is one could be, say, 220 volts and one could be 240 volts. So I've now got as I said on there, with that voltage we were putting in, which is 25 volts, we've got 82 volts. Let's move these over to here, and now let's see what we've got on this tapping. Still 82 volts. Now we've got tappings here, and we've got 1.6 volts. If we go there, we've got 0.8 volts. So if we go there, no, we've got 3.4 from, no, sorry, 0.8 from there, 1.6 for there. So that's look, those three there are looking like a filament winding to me at this moment in time. So let's just go up a bit more now. So now we're up, let's just see, it says 30 volts on the variac, and I've got 36 volts. What have I got coming out of here? Now we've got 113 volts coming out of there. We've got 2.2 there now, and 1.1. So that being the center tap, I think that's the center tap. Yeah, so we think that's this. So it's now beginning to look like this is a filament voltage, filament winding, sorry, and that is the center tap, the end pin over there. It's a bit difficult to show you this on camera. I'll see if I can move this amp across a little bit and see if we can just get the meter in. Not quite. Let's move the camera across. There we go. Now we can. Although the wires are in the way, but we best leave those because we don't want them touching. So the other good idea when you're doing this is to have an amp meter on the variac, because of course if you don't know which way you're putting these on, you could be creating a short on these windings. So the amp meter will tell you if you suddenly get current on this transformer, even at a low voltage you'll get it as well, then you know straight away to switch off. You can use a current limiter as well. So we're back to that again. 115 volts on there. Now on this tapping here, we've got the same voltage as we've got on this one. So at this point, we don't even know if this transformer's got 110 volt tapping. Has it got a 240, 220? We hope it's got a 240, or I'm in real trouble with this because this is not, obviously not going to work otherwise. Now we're at, I've got 50 volts on the variac. Now we're having to be careful now what we're doing. And we've got 175 on there. What we got on this filament, what we think is the filament voltage, 3.4 at 50 volts. Well, if that's a filament voltage and I've got 3.4 volts at 50 volts, then that's telling me that that could be 110 volt tapping. I've also got 175 volts, and what have I got going in? 55 volts, which also tells me that that may be 110 volt tapping. I've now got 92 volts on there, and now we're having to be very careful. I might put some gloves on. 302, maybe not then. What we got on here? 11.6 now I've got on there. So that's not filament. Oh no, sorry, what did I say that? 5.9. Must don't know what happened there with the meter. 5.9 volts. So that is again beginning to look like 110 volt tapping, except we've only got 302 there, so I'd expect to see more than that. Now the question is what's on these wires, and we do need to be careful with this now. We can't just get hold of those. 36 volts, so that 36 volts. So could that be a bias tap in there? But then we've got a centre tap. So this transformer is drawing about 230 milliamps. That includes the variac though. So I've got 3, 4, 1 on there. I've now got 6.6 on, hang on a minute, 6.67 on there, and I'm now, what am I putting through it now? 109 volts. So that's beginning to look more and more like a 110 volt tap. Right, so what I've done this time is, because we were getting the same voltage on those windings here, on these pair and this pair here. So what I've done is I've now paired them up in series with this. I bet someone was shouting, just pair those up in series and you'll get 240 volts. So let's see if we have got the correct tapping now. So we have got 103 volts HT. What have we got going in there? 66 volts. 66 volts. 104. 2 volts. That sounds more promising, doesn't it? So now I'm going to go up to the 110 volts that we had before. And if I've got 3 volts on here, I'll be extremely pleased. And I have 3.5, look. And we've got on there 180 volts. 3.5, half that again, that's the centre tap. So what we got on these wires here, I'm just going to bring this out because you can't see it very well. So there we go, we can see things a little better now. So what I've done now is I have bridged these two tappings, so the tappings here and here, because we were getting the same voltage on these tappings here, whichever side of those we used, and we'd got to 110 volts and we'd got 6.3 on these, which I think are the filaments on there. So now I've bridged that, things are looking a bit better. Now if I go on to this, which I think is the HT, I've got 180 volts and I've got going in there 115 volts. So I'm now up to the 110 volts, which we were before. We'd got about 350 on there or something finishing up. Now I've only got 180, but the main teller that we have got this correct is, that tells us 3.5 volts at 110. We're probably somewhere near with that. Right, we've sorted this transformer out, which you can see here. We sorted out the tap-ins, so we're showing you earlier. So we just take this out. So we're bridging these two together, and that will give us 240 volts off those two. That gives us 6.3 at 240 volts with a centre tap for the heaters, filaments, and then we've got the HT. Now the HT is 372 volts AC. Now when we've rectified that and smoothed it to DC, we'll have 520 volts off this transformer, because it's times by 1.4. I think it's 1.414, but 1.4 is close enough. So we'll have about 520 volts. So this amp's going to have a fair old kick in it. On the schematic for this box, I think we've got about 450. So we have got a little bit more HT. I don't think that'll be a problem though, as long as the caps are rated for it and we can bias it at that, it won't be a problem. Right, so I've been sussing a few things out on this board as well. Now I've sussed the transformer out. This is the HT feed, and this is the AC feed to the diodes, which are in a bridge on there. So those 2 points. This wire for the HT feed went down to that HT fuse, which is on this board there. I have removed that because of dragging this wire all the way down here. More importantly, I've removed the mains fuse, AC mains fuse, because that was also dragged all the way down there to that, and the wire was across the board, and that is no good. We don't want that over there. So it needs to be on the side of the power transformer. So what I've got going on here is a fuse holder. I've got plastic insulator on there. I always put those on just to be safe. And that's going to be the mains fuse. The cable holder for the mains cable is this. No. So we're going to use one of these doofers. You've seen me use them before if you watched some of my videos. We're going to mount that there, drill that hole out. That's going to go there. The mains cable will come up through here. The live will connect to the fuse. It'll then go round here to the switch and then back to the transformer, and neutral will go to the transformer, and so on. Usual deal. The ground for this amplifier from the mains outlet is that. No. So what we're going to do is use this hole here. It's much bigger. I think that's an M5 bolt we'll put in there, and we'll have a star washer on there. We'll have that'll be a real quality ground, really solid, and it's nice and clean on there. So that we're going to use that, and that will give us as ground as well, and that'll make this amp again much safer. So that's what we're going to do there. The filaments, which are these here, as I said before, these are the filaments. This is the HT now, and this is all the mains outlet. So the filaments are going onto this socket here, this, and I think that's the phase inverter. I'm almost sure it is, although I do need to check that on the schematic. Not the best soldering on that socket. It's obviously been changed. So we're going to have to look at that and address that, just tidy that up. And then the capacitors we need to change. We may have to order those. So we need to change the capacitors, because I'm not firing this amp up, as I said, till I've changed these capacitors. We don't want to be blowing this transformer as well. And then when the capacitors are changed, we need to get a bias resistor in here. We've got a bias trim pot. I presume there's a resistor missing from there anyway. I presume there is, because if I check that through on the meter and on there, these are the AC points that are coming in. Just about to see that meter if I just... These are the AC points here that are coming in on there. Just put it onto continuity. And so you can see this is a bridge. So if we pop on to there, you see we've got continuity. We have, and if we pop onto that one, we've got it there. And then if there and there, we've got continuity. So something's missing from there, and obviously that's got to be a drop-in resistor, because there's going to be quite a lot of voltage on there. No centre tap on this transformer, but then this had a bridge on there, so there probably wasn't a centre tap on the other for the HT. We'll have to look on the schematic and see what that drop-in resistor is. We'll probably have to change that, because we've got a little bit more HT than the amp had before. Won't be an issue while we're firing this amp up, because if there's more negative volts, then it'll just run cooler. So that's what we're going to do there. Now this board, we don't need to take it up, because the chassis is open underneath there. So you can see the back of the board. So we're going to change this capacitor for the bias. That is the bias capacitor. That resistor there has been changed, because that looks like a modern resistor. That's 22k. That's on the bias. I might take this out to see if I can clean it, because you can't get to it. I don't know whether it's open underneath, we'll have to see. So I might have to take that out to clean it. There's a electrolytic here that's been botched in, as we saw before. Let me just put another light on because I'm getting over here. So there's electrolytic there we need to look at and find out if that's it. I mean, is that a mod on this amp, or is that actually in there? Don't know. It's certainly not original, is it? Then we've got a couple of capacitors there to replace as well, and then this amp should be recapped as far as the electrolytics go. But then we've got to get down to this area here. We've got this resistor here and this resistor, and that all looks a bit of a mess to me. This I don't like at all, and I don't like these resistors with this pip on here, this metal. I really don't like those, and that's really, again, close to the chassis. Don't like that. So that needs a coat of looking at. We need to tidy all that up. That needs tidying up over there, you can see. And if we just hone in, but we'd already spotted that. And then we can get this amp fired up, and hopefully it'll run. We've got some tubes for it, so hopefully we can find a set of tubes. I mean, this project's on a budget. You know, that's the thing with this amp. It's actually coming to the shop. It's coming in bits. You know, this 100 watt amps these days, they're very difficult to sell. Most people don't want amps this size anymore, and this is a bit of a strange amp. This is one of those love it or hate it amps, so it may take quite a bit of selling. So it needs to be relatively cheap, so we need to I mean, it'll have new capacitors in it and so on, but we want to try and see if we can find some tubes for it, rather than going out and buying a quad of tubes, because then that's making the amp even more expensive and it makes it more difficult to sell. So that's where we are with this amp. But the good news is that transformer is going to do just nicely for this amplifier, and we've worked out where all the windings are, what the voltages are on there. So it's just a matter now of getting this amplifier wired up and making it safe. Right, we've had a bunch of parts come in for this Vox, and we've had some new power switches come in. As I said before, I don't care for these power switches, and one of the reasons is that these terminals are a bit close to the top of this lip on this chassis here. Somebody's also damaged that slightly, but never mind, obviously it's not going to be in there anyway. So yeah, so I'm not mad keen on those. If this chassis was to get dinted down or bent, that could quite easily catch on there. And how many chassis do we see that's bent and twisted? Quite a few. Now the standby switch, so if we look close in there, you can see how close those terminals are to that capacitor. Very close. Although that is the standby switch, that's not really good practice, is it? So we need to get that switch out and put a different switch in there, because that's just not good. So that's what we're going to do. We're going to get the switches, and all the capacitors have arrived. The cans have arrived, the 220s, which will be wired in series. So they've arrived as well. So we're going to start putting this amp together. I've been having to think about this power section in this amplifier. So we've got the new power switch in. Turn that sideways, and we've put on one of the on-off. You can just see it there. Sorry about that. We've just got one of the on-off badges there on the back of it. The standby switch, which is here should be through this hole here, is right over this cap, as we said before. So I've had a bit of a think about that, and I'm not going to fit a standby switch on this amp. I don't subscribe to standby switches, for one thing. the capacitors are rated at 700 volts, so they're way over what this transformer kicks out even before the, you know, any powers or any current is drawn. It's not the problem with having that a standby switch in there is right over that capacitor is that if it comes loose and somebody starts tightening it up and twists it and it ends up contacting with that capacitor on there, it could be really dangerous. And I just think it's ludicrous to put a switch right above a capacitor like that. So what I'm going to do there is I'm going to put the pilot light in there. The pilot light's plastic. I've ordered some pilot lights, 6.3 volts, and I'm just going to run that off the filaments. And that, because the other thing is blocking this hole up. Well, if I put a grommet in it, a child can pull it out. My little finger just won't quite go in, but a child's would. Well, look where that's going to go. That's just going to go right onto that terminal. So we need to put something in there that's permanent. The other option is plating it, but that's just a nightmare to do that. So it makes sense to put the pilot light in there. We've only got this titchy pilot light in there anyway, which is a tiny hole, which is we can just put a grommet in there. Even if it's pulled out, it's not such a huge deal, that one. There's another strange thing as well. Actually, that the pilot light that came out of this thing, the small one, was also 6.3 volts. And instead of running it from the transformer to the pilot light, they've run it all the way down here to this preamp tube, and then come all the way and brought all this AC. If we look at that, then they've brought all this AC under the pots, you know, and across here, where, you know, to cause more interference. You need to keep that away from signal if possible. So we're going to be removing this wire, and we're going to be wiring the pilot light straight from here. Right, let's just have a look at what we've done then on this power transformer. So we've got the feed coming in there. We've got one of these glands on there. We've got feed coming in there. Then that goes across here, goes round into the switch, which you can just about make out. If I just bring the camera in there, out of the switch, into the transformer, through the series loop, and out through the neutral. Through the series loop, out through the neutral there. You can see that's all done. We've got the ground ready. We've got an M5 bolt for the ground with a star washer. We've got some insulation under this fuse holder just for extra protection there, and that should do us. So I'm going to wire this ground up, and then we're going to make a start to wiring up the HT and the filaments. And we'll say we're waiting for our pilot light, which goes through there, which you can see is much better than the standby switch going there. You don't need a standby switch anyway. They're a gimmick. Don't blast me in the comments now. Don't blast me in the comments. So yeah, and when we've done all of that, done the HT and those caps, then we could get down to here. If we just move in to this side, and we've got the capacitors that go on here as well. There's three there. One is a double, that'll be 32, and these other two are 220s. Took me a minute or two to remember. And I think they're feeding the screens from what I can see. Am I right? Yes, I think they are feeding the screens. But we've got I think we need to address that. Yes, mind you, they're both live, but even so, you know, like wires being like that, because if that forever for any reason burnt through, it's bare. But yeah, they're both live anyway. So, and then there's this mess with these. Somebody's obviously tacked in all these resistors, and they're just willy-nilly, and you can see we've got this. So we need to address that as well, and we need to do all that before we can run this amp up. Right, we keep plodding away at this Vox. So we've got all the primary done now. These wires you can see here for the pilot light, which is on the front. I'll have a look at that in a minute. I've actually redone all the terminals on this board because they looked a bit tacky. I've wired in the AC now from the transformer on the secondary. You can see we've got this quite heavy duty cable. I've changed the diodes, and these are seriously heavy duty 5408s. I've had to drill the holes out a little bit to get them to fit, but they're heavy duty. There was no point leaving the other diodes in, which were iron 4007, something like that. There was no good leaving those in because this has had a transformer, we presume had a transformer failure, and we don't know how much hammer those diodes have had whilst the previous transformer was failing. It's always, well, I always change them anyway. Everybody has different things, but I always change the diodes. If there's been a transformer issue, change the diodes. I always do. So that is that. Now then, this is the ground from the bridge rectifier, and that is precariously tacked onto this capacitor bracket, and we're going to have that removed, and we're going to bring that to here on this ground that we've got. Right, I made a bit more progress on this Vox, and it's proving a bit of a challenge from a safety aspect, that is. So we've got the fuses in now. That's for the AC, that's for the HT DC there. We've wired in the diodes, new diodes that we've seen. We've wired from the diodes from the DC. We've wired up the capacitors in series. We've done the ground tag there, so we've got that. We had that bit of a rubbishy ground for this capacitor on the capacitor mounting screw, which was rubbish. So we've put them all in there. Made a good job of that. Now I've run the center tap wire from the capacitor here, and which also goes from the HT from the diode from it's rectified to DC, then it's run down to the center tap of the transformer. Spitting words today. Now I've run that down the back, and it was run down the front. The reason I've run it down the back is because we've got the preamp tubes here, and we've got AC heaters filaments, and so I've put it down the back. I know we've got filaments on the output tubes, but it matters more that we keep it away from the preamp tubes than the output tubes. So if we've only got two choices, we'll go for the one that's going to create less noise, hopefully. Now that brings us down to this corner, and this is where things, from a safety aspect, and I've found a few things on this amp that I really don't like in this design from a safety perspective. And one is this capacitor here, which obviously I've removed right underneath the jack socket. So someone comes in here to tighten this up, they put the hand down there, and they're on the fingers are on the terminals of the capacitor. Now that's okay, obviously, if the amp's switched off and the caps have discharged. But if they've not discharged, then they're going to get a bit of a belt off of that. The other thing is it just not a great idea, is it, just to have 500 volts of DC? They're firing the screens up, they're smoothing the screens. There's going to be nearly 500 volts there, 450 volts. It's not a great idea, I don't think. And I think if you look at these two side by side, it would make sense to put those in series. Put both of the 220s, because both of these caps are 220 in series. Like we've got on this side, we've got 220 in series, gives us 100 microfarad. They're actually 200 on the schematic, but it's around about 100 microfarad, so 110. So we've got on here the same for the screens, 2 in series, because of the high voltage. Remember, wiring them in series doubles the voltage capability of the capacitors. So theoretically it would make sense to put them side by side. I think the reason they've put them across from one another is because this capacitor here is in series, and so therefore it has a balancing resistor on, which also acts as a bleed resistor, which also always makes sure that cap's got no power in it. and I wonder if that's why they've put those across from each other, because surely it just makes sense to why those would be series together. Whether that they've done that, I don't know, but I'm not happy about having a capacitor there. Now, I've looked around on this chassis to try and find somewhere else to put it, and there really isn't anywhere. So another issue with this amplifier where safety is concerned is that there's no plate over this board. Not a huge deal if you're in here and you know what you're doing, but as we know, people come into amplifiers and they get a problem with it, and first thing they think is, oh, it's the tubes, it's the valves, whatever the tubes, we call them valves. They're into the amp, they forget to unplug it from the wall, they're working in here changing valves, and suddenly they catch the terminals on the board. I don't think this has ever been plated, and what makes me think that, for a start, is these inductor wires going through these holes, which have no grommets on them, but they're only inductors, so it's probably no big deal. Right, here's the answer to it. So what I've done is I've got this, it's just a blanking grommet, and I've slit through with the Stanley knife where the pins are, and I've pushed it down and onto there, and then I'm just going to put some shrink tubing over those when they're soldered, and that should give some protection. It's the best we can do, really. They're just mounting this anywhere else is just going to be a no-no. Now this is a 32-32, which I'm now going to put in here. Just move the camera around. So I'm now going to put the 32-32 in there and the two 120s side by side. That makes sense. The other problem is, of course, if I was to put the 120s there, I can't get this on because the balancing resistor is going to be above it, and then it's just going to be live again. So that's the best way to wire those up. Makes sense. Now the other thing that I've done, and I'm just going to turn this amp over again. So if we look in here, if you remember, we had all these wires bodged onto this little pin there. There was at least 3 of them, and then we got another resistor coming out of there, which eludes me where it's gone. Another one of these 7 watters, and they're on the schematic as 7 watt, so 7 watt it is. So I've put this tag strip in, and this is solid. I've drilled it into the board. I've got spring washers either side on both screws, screwed that in, and now we're just going to end up with 1 wire on there, and we're going to clean up that mess, because this is the original centre tap wire that we had in that thin stuff, and we're going to clean that up and just have 1 wire on there, and we're going to try and wire all the balancing resistors, dropping resistors. They're all going to be wired into this, and so it's much neater and of course much safer, because we've got these capacitors, these resistors floating around like this, and that one's already snapped off, look. That's just like, yeah, right, so that's no good. And then we've got this resistor here, and I'm not sure what's happening with this resistor, and I can see that that's been recently soldered, and that resistor is going to ground, but on the other end of it, it's going to live on those capacitors. Now bearing in mind how much voltage this amp's got in it and how much current draw with these valves, that's 5,000 ohms. Is that 5,000 or is that 50,000 ohms? 50,000 ohms. 50,000 ohms wired to ground. So I'm going to have to look into that, because that soldering there is fresh, well, fresh-ish, and it's certainly not factory, is it? So there's something not quite right there, so we need to check on the schematic about that. Right, we're having a look at this schematic, and we're looking, just find it something to point with, we're looking at these capacitors here. These are the 2 capacitors that are at the far end where the output transformer is. That's the 100R resistor that's coming off the feed from the B+, and then that's going down to these capacitors. They're in series, and that's going to ground. There's the screen resistors there, which are 1k. So what isn't on there? That 50,000 ohm resistor is not on there. And that resistor, we'll just have a look. So what is this doing fastened to the B plus and then fastened to ground there? See that? I wonder if that's the reason that this transformer was blown on this amplifier, because somebody wired that in. The current that must have been drawing to ground. I don't know. I don't know why that's there and why it should be there. It's not, obviously it's not on the schematic, and it shouldn't be there, should it? Now if we look there, you can see that's the capacitor that we've got, that we've made that blanking grommet there, which is it doesn't actually look too bad in the end. I thought that would look really messy, but it's not too bad. So all we've got to do now is put a couple of wires on the lives, and we just put some shrink tubing over them, and that will protect anyone who goes in to try and tighten up that jack socket should it come loose. And there's always somebody that will do it. So we finally got all this together. We've got these drop-in resistors on here. We've got that all wired up. Now we've got to get a ground on this capacitor here. That's the ground for the screens, so we just need another ground. And I have upgraded a lot of the grounds on this amp because they weren't very good, such as that one there, where you can see just very flimsy ground. That's only on the ground for the speakers, so that's not a huge deal, but when we're dealing with nearly 500 volts we need a decent ground. Also, if we look at our capacitor down there, you can see we've insulated those, and we've got that insulation, that rubber grommet thing, blanking grommet there, and that's made that safe. So now if anybody's in here tinkering to tighten up the jack socket, well, because you never know, people do daft things, don't they? I do daft things all the time. Right, we've done quite a bit of work to this amp, so let's just have a look at what we have done now. One thing I've done is I've connected up the bias feed, and I've used those 3 wires that we had protruding, that we insulated, if you remember, just to keep them out of the way. I did a bit of a test on those, and they came out with enough voltage to do this bias. So the 3rd wire, the black one, I've just cut that back, we don't need that. So the bias is connected up. We've got ground lug there for the bias, and that ground lug is for the filaments. Now the filaments we've not connected up yet. I've removed some of the filament wires that were dangling around, and you can see it's looking much tidier in here now. There was a hum balance pot, well, it was a virtual center tap, that just fell off. Since I went near it, it just dropped off. So that was gone. I've also just been looking at this that's been wired up, this socket, and that don't look very good. So I'm going to visit that and have a look at that. You see there. But we've got all the wiring's done now. We've rewired all this amp, all the HT. We've got 120 ohm on there instead of 100. We've got a 2.2k. There was a 1k resistor missing. I don't know where, drop-in resistor. That dropped the voltage from the screens down to the phase inverter. Don't know where that was because it were missing. So we've added that. We've used this, as I say, we've used this thing here. It's just to try and make this more safe. You can see now we're all finished down there, and that's really safe now. And we've got a ground in there. And we've drilled another. Let's see what I've done with that. There it is. Let's see if I look it. We've drilled another ground out for that. So, and that's done properly. So we're going to put a dribble of voltage into this now, and just make sure that we've got voltage everywhere we need it to be. So let's look at the plates, which reminds me I need to redo these cables because they've been hacked. So we've got 34, the other plate, 34. Right, let's check the screen. Yep, screen, again, yeah, screen, yep. Good, so we've got voltage there. So we've got voltage up to our screens. Now we need to see if we've got voltage on the phase inverter. So if we come down here, that is pin 1. So we've got voltage on the plate. Yep, and pin 6. Is that pin 6? That is pin 6. Yep, 34. So that's good. So let's move down the line with these. Let's see if I can move this a bit further in so you can see. Might be struggling here a bit. Let's try the plate resistors. So that plate resistor, yep. Plate resistor, yes. What's that? Is that a plate resistor? Ah. Try that plate. Yeah, I've got voltage on there. Try this one. Yep, got voltage there. And this one. Yeah, got voltage on there. Not as much as on the others, but we've got voltage. Yep, that's good. So we appear to have voltage to everything in there. So that's good. And we always do this. We're not, even if the filaments were wired up, which they're not, but even if they were, I wouldn't be putting the tubes in until I've done these preliminary tests. So it is not good to put the tubes in if you've done a lot of wiring. Better off checking your work first and making sure that you've got that right. So let's just turn our attention to this bias now. If we can just get this in there pretty easy. And you can see I've got -3 on there, but I've only, at the moment, I've only got a small amount of volts on the variac. We need to find -40 volts, 192 volts there, 195 volts, and there's our -40. Now we'll need a bit, I mean, we don't use negative volts to set the bias. This is just a rough guide. We know if we've got less than -40, we're going to be in trouble, and the reason for that is because this power transformer has got more HT volts on it, so we need to have at least 40 volts. Now let's try the bias preset pot. That's gone up to 48 volts and has gone as low as 32, so that's working. Just done a few more tests. Remember, we'd got a bit of a voltage drop on this valve socket here, and we shouldn't have had. So I did a bit more testing, run some more voltage through, and this capacitor is getting red hot. Now this is a bit of a botch up. It originally went there and there, so I don't know what's going on with that. I don't know whether that cap's dead short or whether it's they put it in and while they've been testing and messing about, it's gone dead short or whatever, but that's getting red hot, which tells me there's a short on it. So this video has gone on quite a bit now. I have got some more, as I say, I've got more bits to do as well. So what I'm going to do, I'm going to make this part 2, wrap this one up. We've got to wait for those capacitors now, because obviously we've got a problem there. I want to lose those and wire that back up how it should be done. We've got the filaments to wire up. So that's what we'll be doing in part 3. We'll be wiring up the filaments. We'll be replacing these 2 capacitors there. There's another one there needs replacing. It's there. That one there needs replacing, that electrolytic. And then what we're going to do is select some tubes. We've got an array of tubes that came with this. So we're going to select some tubes, and we're going to run this amp up, turn the bias full up. So we've got loads of bias, and we're going to run this amplifier up and see what happens. I'll be surprised if this runs up first time with no problems, but yeah, let's just keep his fingers crossed, because we've got all this stuff on the board and things. Once we've got this up and running, then we're going to be checking these coupling capacitors to see if any of them are leaking. But anyway, that'll do it for this one. So thanks for watching, and you all take care, and I'll see you all in a future video. Bye bye for now.